Okay, so we're checking out your assignment 8 turn-in for squash and stretch. These are really cute. So good job on the cuteness factor. I really like these little guys. Fun to watch them do whatever they're doing, like little jellyfish or something, or Pac-Man ghosts. But, you know, cuteness aside, as far as the animation goes, you do have some squash and stretch going on, so that's good. There's one important concept, though, that's missing from your squash and stretch, and that is the idea of displacing mass. Okay, so to kind of demonstrate what I'm talking about here, I have an amazing drawing for you that I've done. Took me several hours, of course, but anyways, I kind of like to use the example of a balloon, like a water balloon, okay? So just kind of imagine for a moment that you have this water balloon, and you're about to place this weight on it, okay? So if you imagine this weight pressing down on this water balloon, it's not going to just simply scale down in the y direction, if you can imagine this in 3D space here, alright? Because if we just adjust it only in the y direction, alright, then, you know, we've kind of squished it down, but this balloon, you know, here in this illustration, looks like it has a lot less water in it than this one, right? So obviously, you know, we don't want the water to just kind of magically disappear somewhere when we squish it down. What actually happens when we squish it is that the water has no place to go in an up and down direction anymore, so it then has to go outwards and expand outwards, okay? So basically, as you're putting pressure in one direction, the balloon is going to balloon out in other directions. So, you know, again, when you see this kind of thing where we haven't really accounted for the displaced water and it's just kind of, you know, evaporating into thin air, we get something that looks smaller than the object was originally and could cause the object to look like it's just shrinking, okay? Where really we want it to retain its mass and just kind of displace it in a different way, right? So to apply that to 3D, for example, we can take this guy who's stretching out right now, and you can see at the moment we've got this 1.27 value indicating that there's a stretch going on there, but the scale X and the scale Z are still at 1, which is just your regular scale, okay? So ideally for a stretch, we want those to be a little bit smaller than they normally would be. So it's pulling it out, so it's thinning out in these directions, okay? And gaining mass in the y direction, alright? Or gaining scale, I guess. So make sure you go through and do something like that. And you can key that, okay? Same kind of concept when they're squashing down, alright? So when it's squashed, just like the balloon, it should be displacing mass outwards, alright? So in your scale X and scale Y, it should be a little bigger, alright? And let's try 1.3. And we'll go ahead and key that. I'll do the same thing here, since again we're squashing at this point. And we'll try, what did I say, 1.3. This is all kind of an eyeball sort of thing, you know, just find what you think looks right and key that. Okay, so we've got that squash, stretch, and squash. And now that I'm looking at it, you know, maybe my squash is a little bit dramatic. So, you know, I can adjust those and change those all day if I want to, but you know, you can kind of see the idea just based on that example of going through and making sure that you're not gaining or losing any mass, that at all times it looks like this creature is deforming, but that it's still retaining the exact same mass and volume, okay? So you can kind of see the difference there between this guy and the other ones. And you can adjust the others as well, okay? And it's going to give you a more effective squash and stretch, alright? So let me know if you have any questions about anything that we went over, and happy animating!